So today we are here in the office. We got called by our boss this morning. So he said he's got a special task for regarding the rocket ship prototype that has a mission to go to Mars in the future. So let's find out what the boss wants later.
Later.
So our boss needed a team to analyze the data from the recent rocket ship prototype to Mars. And I was told, true story by the way, I kid you not, there were 3 teams for the mission. First, it was the Fast and Furious family. Oh my god. Next, we have the Avengers. And then he had us. And then we got a job. Again, true story by the way. So, let's get to work.
A few moments later.
So, after weeks of looking at data, what do we got, guys? Or shall I start first? So, to recall, this task was given to us to analyze the data of weight of memory chips that is used in the Man to Mars mission. And the reason our team got picked was we are quality control engineers, and as this type of engineers, we have a responsibility. So our responsibilities are analyzing and clarification of requirements, plan the process of testing, write the test cases, conduct functional testing, identify problem areas, discuss fixes, track the life cycle of errors, retest, fix defects, analyze testing, optimize the testing process, analyze the teamwork processes, improve processes, and maintaining the test documentation. So, for this project, we also use quality tools, which has 3 of them that we have used, which are the check sheets, the histogram, and the control chart. So there are actually 5 other quality control tools, which are the process flow diagram, Pareto diagram, cause and effect diagram, scatter diagram, and that's all. So who's gonna go next?
How about I go next, Azme?
Sure thing, go ahead.
All right, thank you. As mentioned by Azme, our team used 3 quality control to analyze the output of memory chips production of our team. The 3 quality control tools, which are check sheet, histogram, and control chart. The first one is check sheet. A check sheet is a basic form with a predefined structure that can assist the user in capturing data consistently throughout the course of a collecting period. The main purpose is to ensure that the data are collected carefully, systematically, and accurately for process control and problem solving. There are two provide snapshot of the process being studied and reveal underlying patterns including the frequency of an event or activity. The advantage of this quality control tool is simple and effective way to display data. It is a good first step in understanding the nature of the problem, and it provides a uniform data collection tool. resulting in clear visualization of the situation and organization condition. In the other hand, checksheet is lacking the capacity to investigate a high priority problem. Next, histogram is a graphical summary of a set of data that describes the amount of variation in the process where it is a form of bar chart. It graphically illustrates the process capability and the relationship to the specification limits and the nominal desired. It also indicates whether there are any outliers. A histogram's major benefits are its simplicity and flexibility. It may be applied to a variety of scenarios to provide an in-depth look into frequency distribution. However, histogram not allow to read exact values due to the data is grouped into categories and it uses only with continuous data. The last one is control chart. A control chart is a graphical tool for studying how a process changes over time. The data plotted in time order. The average is always shown by a center line, an upper line for the upper control limit, and a lower line for the lower control limit on a control chart. Upper control limit and lower control limit lines are derived from historical data. By comparing current data to these lines, we can draw conclusions about whether the process variation is consistent, which is in control, or is unpredictable, which is out of control, were affected by special causes of variation. I think that is all for me. Hey Syafiq, how about you show us the analysis of our findings?
All right, Mr. Syahmi, I will show I will show the implementation of method for this project. Okay, the first method I will be using is tally sheet. So, by constructing tally sheet, the highest frequency of memory chip production for every day are obtained. So for Monday, the highest frequency of memory chip production was 775, which the weight range from 3.35 to 3.419 gram. And then for Tuesday, the highest frequency of memory chip production was 767, and the weight range is from 3.91 to 3.979 gram. And then for Wednesday, the highest frequency was 770, and the weight range was from 3.56 to 3.629 gram. And for Thursday, the highest frequency of memory chip production was 766, uh, and the weight range from 3.21 gram till 3.279 gram. And for Monday until Thursday, the highest frequency of memory chip production occurred in the morning shift. Meanwhile, for Friday, the highest frequency of memory chip production was 774, which the weight range is from 3.770 until 3.839 gram. That's for tally sheet. Now moving on to the histogram. Then from class interval of 0.07 and frequency obtained from the tally sheet constructed, only then the histogram can be constructed. Two histograms are constructed for each day, which cover morning shift and afternoon shift. From all the histogram constructed, it can be concluded that the histogram produced symmetrical and uniform in pattern, where is no such pattern as skewed to the right, skewed to the left by model or by multi-model are produced. Okay, moving on to the next one, which is control chart. There are two control chart we are using, which are X bar and R control chart. X bar control chart all days shows control pattern with no noticeable pattern. This indicates that all the processes are under control. For art control chart, all days shows regular pattern except for Monday and Friday. On Monday, the graph shows a fluctuation or spike caused by subgroup 23. And then on Friday, the graph show a sawtooth pattern. This indicates that the processes for this day should be improvised.
I see that we are all well knowledge on our findings. So let me just conclude it. As a conclusion, based on the histogram results for the class interval at 4.0495 to 4.1195 is the least number of frequency, which is good because we don't want the value for product to be too far from the ideal value, which is 3.56 gram. The histogram also shows the consistency throughout the system shift, but still less in accuracy. This can be fixed or improved by creating a response plan on the manufacturing, such as AQL or acceptable quality limit. Acceptable quality limit is an important standard used in the quality control industry. It's defined in ISO 2859-1 as the quality level that is the worst tolerable over the course of many inspections. To assure the quality of product and services, we need to employ quality control tools. In this context, as precise data are not always available, fuzzy sets theory can adequately model the processes in which observed data are vague. Researchers have focused on fuzzy control charts that accommodate uncertainty due to fuzziness. As for the output suggestion, the best output value should be 10,000 units per shift or 20,000 units per day. This is slightly less than the current output value because by lowering the targeted or suggested total output unit, we can focus more on the quality of the product than the quantity, but at the same time, not decreasing the value too significant. Don't you all agree?
Yep,
Yes, agreed.
absolutely.
Yeah, yeah, sure.
So that's all.
Yeah, I think we're done for this meeting. So let's go and have lunch, guys. Let's go.
Let's go.
Let's go.
Sure. It's okay. I'm on a diet.
Okay.